Very good morning to all my dear students. So today we will discuss the second part, chapter Deadlock. In previous class, what I've discussed, how deadlock is created. When a process is requesting a resources, if the requesting resource is held by another waiting process, then we can say that the system may or may not in deadlock state. Now here the important term comes may or may not. We cannot perfectly say, or without any experiment we cannot claim that the system is in deadlock. To satisfy the necessary conditions of deadlock, there is four important conditions. If four important necessary conditions is satisfied by any system, then we can conclude that the system is in deadlock. And remember one thing, those who are not familiar with that deadlock is an unwanted application. Unwanted application or unwanted thing means, say, when we say this, my system is in going to hang, means perform nothing. The system is in idle state. The CPU utilization is maximum. This is one condition when we press Alt Control Raise, Alt Control Del, and open the taskbar to resolve this type of situation. Now, here, come to the point. The necessary conditions of deadlock. First one is mutual exclusion, then followed by hold and wait, then no preemption, and last one is circular wait. Now, I will discuss one by one. Mutual exclusion. Mutual exclusion means the access should be in mutual exclusive manner. Means one at a time, no concurrent access will be allowed, and resources must be held in non-shareable mode. In case of deadlock, resources must be held in non-shareable mode. Now, second point, hold and wait. Each and every process in the deadlock state must holding at least one resources and is waiting for additional resources that are currently being held by other waiting process. So hold and wait situation is looks like this. See, in a process it should have both type of edges, requesting edge as well as assignment edge or claim edge. Now the third point is no preemption. Preemption means release. So no preemption means resources cannot be preempted. No preemption means resources are not released in the middle of the work. They released only after the process has completed its task. So no preemptions, resources cannot be preempted voluntarily. And the last condition, circular wait. As we know, when we represent any deadlock graph, it is represented through a direct resource allocation graph. And the graph shouldn't, generally it is preferred that the graph shouldn't have any cycle. But if the graph having any cycle or the same node is repeated twice, then this circular condition if exists, then we can say the system is in deadlock state. So to satisfy the necessary conditions of deadlock, any system should satisfy all these four necessary conditions of deadlock. Then we can say that the system is in deadlock state. Some of my students ask me, sir, I'm not clear. What do you want to say? Means what is mutual exclusion, hold and wait? For that purpose, I'm giving real life example. The real life example here, it shows that there is a canvas. As we know, what is canvas?